February 2026, Elmendorf-Richardson Air Force Base, Alaska. Hangar Bay 4, 3rd Wing. A pilot designated only as Talon 1 stands at a mission planning table, staring at a threat overlay he was not expecting. It is a penetration profile. 400 nautical miles into a simulated PLA integrated air defense network. No wingman, no stealth airframe. One F-15EX Eagle II, and one system the Air Force has not yet declared fully operational. The AN/ALQ-250, EPAWSS. The threat rings show HQ-9B batteries with engagement envelopes extending 200 kilometers. Behind them, simulated J-20 combat air patrols in a coordinated kill chain. The first 90 seconds of ingress, from crossing the IADS boundary to reaching weapons release range, is what the brief calls the critical window. In previous simulations without EPAWSS, aircraft in this role did not survive that window. We will come back to Talon 1 and what he decided when the mission clock started. But to understand why this scenario exists at all, you need to know what changed in the electronic warfare calculus 18 months earlier. The F-15 airframe has been in continuous production since 1972. The 3rd Wing at Elmendorf began transitioning to the F-15EX Eagle II in 2023, replacing F-15CD models that had flown since the 1980s. The EX variant brings a fly-by-wire control system, the AN/APG-82V-1 ASA radar, and a payload capacity of 2,900 pounds, more than any other tactical fighter in the U.S. inventory. On paper, the most capable strike platform America has built without relying on stealth geometry for survivability. The question since the EX entered service: does the airframe survive a high-end threat environment without stealth? That answer depends entirely on electronic warfare. And electronic warfare, until EPAWSS, was the F-15's weakest system. The legacy AN/ALQ-135 internal countermeasures set entered service in the 1980s, designed around late Cold War Soviet radars. The problem is that 2026's threat environment looks nothing like 1985. China's HQ-9B operates across frequency-agile bands with low probability of intercept waveforms specifically designed to resist jamming. It operates as part of a networked kill chain, a single aircraft tracked by multiple systems simultaneously, sharing data through a common operational picture. The ALQ-135 was not built for that. An F-15 flying a strike mission into a modern PLA IADS with legacy EW is not suppressed. It is visible. BAE Systems received a $2.9 billion contract to fix that. The AN/ALQ-250 EPAWSS integrates directly into the F-15EX fuselage, replacing the ALQ-135 at the hardware level. Unlike podded systems such as the AN/ALQ-184, EPAWSS occupies no hardpoints. The F-15EX carries its full strike package and its full electronic warfare suite simultaneously, all 2,900 pounds of payload capacity untouched. Previous EW-equipped F-15s flew with reduced weapons loads. EPAWSS removes that trade-off entirely. Here is what is most surprising about EPAWSS. It is not primarily a jammer. The system integrates a full-spectrum receiver suite that simultaneously monitors and classifies radar emissions across multiple frequency bands in real time. It builds a dynamic electronic order of battle, a live map of every emitter within detection range, categorized by type, threat priority, and engagement state. In combat, that means the pilot knows which systems are tracking him, which are in search mode, and which are guiding a missile before the threat system completes its targeting solution. That is not jamming. That is intelligence collection at engagement speed. The jamming component then operates against that picture with precision. Rather than broadband noise, the approach modern radar designers have specifically engineered around, EPAWSS applies targeted jamming against specific emitters at the most vulnerable point in their track cycle. According to Aviation Week reporting from late 2025, this approach demonstrated meaningful effectiveness against frequency-agile radar in contractor testing. Specific figures remain classified. The Center for Strategic and Budgetary Assessments estimates EPAWSS provides significant survivability improvement over legacy EW configurations against peer threat IADS. An F-15EX with EPAWSS is a fundamentally different aircraft in a contested environment. One detail worth noting from the technical literature: EPAWSS is a deliberate inversion of how the Air Force has approached non-stealth survivability for 30 years. The old model was reactive: detect a threat, generate noise. EPAWSS is active and cognitive. It processes the threat environment faster than the threat environment can process the aircraft. That is a conceptually different approach to survivability, with direct implications for how the Air Force thinks about fourth-generation platforms in a Pacific conflict. Now consider the adversary. China's J-20 achieved initial operational capability in 2017. As of mid-2026, the PLA Air Force operates an estimated 200-plus J-20 airframes. The J-20 is a fifth-generation low-observable heavy fighter optimized for beyond visual range combat. Its PL-15 missile has estimated range exceeding 200 kilometers, comparable to the AIM-120D AMRAAM. The KLJ-5 ASA radar operates with low probability of intercept waveforms. In a straight detection contest, the J-20 is a serious threat to any fourth-generation aircraft. That is the consensus of publicly available U.S. intelligence analysis. Here is the take that will get pushback. The F-15EX with EPAWSS is not trying to beat the J-20 in a stealth contest. It cannot win that fight. What EPAWSS does is change the terms of engagement. Instead of stealth versus stealth, the F-15EX competes on electronic warfare. And in that domain, 40 years of U.S. investment creates an asymmetric advantage China has not yet fully closed. The J-20's radar warning receiver capability, the EPAWSS classification speed, and the relative sophistication of American versus Chinese EW processing chains are where the real competition is, not in radar cross-section. What do you think? Does a fourth-generation airframe with advanced EW belong in a high-end Pacific scenario? Or is the survivability gap too large to bridge with electronics alone? That question is live in Air Force planning right now. If you want to understand where this debate goes next, subscribe. Next week, we are breaking down the Air Force's 2026 Force Design Update and what it actually says about the F-15EX's Pacific contingency role. In the fourth quarter of 2025, the 3rd Wing conducted integration exercises under the Alaska Aggressor program, using F-15EX aircraft in EPAWSS evaluation configuration against a layered threat environment built from known PLA IADS architecture. What the Air Force released through a December 2025 Air Combat Command statement. EPAWSS demonstrated effective operation in a dense electromagnetic environment and met program performance thresholds. In program management language, that is a passing grade. The February 2026 Elmendorf evaluation was not theoretical. It was the next step in a validation process already underway. The integration phase hit one significant obstacle: electromagnetic compatibility. Ensuring EPAWSS does not interfere with the F-15EX's own radar, communications, and navigation systems. BAE Systems and Boeing engineers worked through frequency deconfliction within the airframe through 2024 and into early 2025. The solution was hardware shielding and software-defined transmit schedule management. According to Aviation Week reporting from January 2026, the final configuration resolved compatibility without degrading EPAWSS effectiveness. The system transmits the aircraft's own systems function simultaneously. The strategic implication is not primarily about the aircraft, it is about numbers. The F-22 fleet is fixed at 187 operational aircraft. The F-35 fleet is growing, but distributed across Air Force, Navy, Marine Corps, and allied nations. A 2025 RAND study examining Pacific Air Campaign scenarios found that stealth asset availability becomes a critical constraint within the first 72 to 96 hours of major combat operations. The Air Force needs aircraft that can operate in contested airspace that are not F-22s and not F-35s. The F-15EX with EPAWSS is that aircraft. Not a replacement for stealth, a complement to it. The jet that goes where stealth assets are too scarce to allocate. In practical terms, This produces a high-low mix doctrine the Air Force is operationally implementing. F-22s and F-35s penetrate the most heavily defended target sets. F-15EX, with EPAWSS and JASSM-ER. The AGM-158B, range roughly 925 kilometers, operates at standoff, using EPAWSS to survive the approach and the missile to reach targets inside the defended envelope. The F-15EX never enters the terminal threat zone. It has to survive long enough to release. That is the survivability requirement EPAWSS was specifically designed to meet. Will the F-15EX with EPAWSS prove sufficient in a real Pacific engagement? Comment yes or no. February 2026, Elmendorf-Richardson. Talon 1's mission clock starts. The F-15EX lifts off runway 6 into the scenario. EPAWSS comes online at the IADS boundary. The system builds its electronic order of battle emitter by emitter. The first simulated HQ-9B contact is classified and prioritized before the engagement envelope is reached. Precision jamming applied at the optimal point in the track cycle. The kill chain is interrupted, not silenced. Interrupted. There is a difference, and in this scenario, the difference is survivability. Talon 1 reaches weapons release range. The evaluation board has the data. The assessment goes to Air Combat Command. The F-15EX with EPAWSS survives the critical 90 seconds. The Air Force has not published those results. What they have done is continue the program and continue flying the scenario. That is its own answer. The F-15EX will not replace the F-22. EPAWSS will not replicate stealth. The question is not whether a 4th-generation airframe with 5th-generation electronic warfare is the ideal solution for a Pacific air campaign. The question is whether it is a viable one, and viable means survivable long enough to matter. For now, the evaluation says yes. The J-20 fleet is not standing still. The PLA IADS architecture is not standing still. The next iteration of this scenario will be harder. It always is.